Right. This is the course on decision modeling, and I am Professor Biswajit Mahanty from the Department of Industrial and Systems Engineering of IIT Kharagpur. Now, what are we going to cover in this particular decision modeling course? We shall cover 4 broad topics. The first one will be decision analysis, the second one will be queuing theory or waiting lines, the third one will be simulation, and fourth one will be network models. So, these are the 4 broad topics we shall cover. Each one we shall put around 2 weeks time, right, 2 weeks for decision analysis, 2 weeks for waiting lines, 2 weeks for simulation, and 2 weeks for network models. So, total it will be an 8-week course. Now, question is that why this course? If you see this particular slide, you can see that first of all decision modeling is an operations research course, right. So, most of the management schools they teach this course under the term quantitative models. So, it is widely recognized and a known course, and it helps people in making effective decisions, right. Now, if you look at this, effective decision making is become a very essential part all over the globe. After globalization, we are seeing that the low hanging fruits are not available anymore. If the companies have to survive, they have to optimize their manufacturing as well as service operations, right. And in order to do that, it is very important that they optimize their operations, and operations research help them into making suitable decisions. So, here we are going to cover some of the very important decision making tools and techniques in this particular course. Another one is that who are the people from industry who will be benefited from this course. Again, the answer is very simple and wide, that almost all types of manufacturing and service industry people will be benefited from this particular course, and UG and PG students of all fields of engineering as well as that of management can also attend this course. Before I move further, let me also tell, since I just now said that decision modeling is operations research, what is not covered. If you look at this slide, we are not covering these all important topics of linear programming, non-linear programming, heuristic methods and project management. Obviously, there are many other topics of operations research, but we are not covering them. It is a short course, only some important topics are taken up. If you really need on these topics, then you have to look for other courses. Who can attend? Once again, it can be attended by engineering students, management students, industrial engineering students, and also economic students. Economics or humanities related students can attend this course. Now, about these 4 particular modules, what is being covered very quickly, let me give a little bit of introduction. You see, whenever we try to make decisions, it is very important that we really understand whether the decision making is happening under uncertainty, risk or certainty. If it is certain, then the decision making outcomes are known, alternatives available are also known. But if it is decision making under risk, then we know the outcomes with some probabilities. So, question is, which decision making alternative should we choose? And all of these are represented in the form of payoff matrices. It basically tells that if I go for a particular decision alternative, right, and a given outcome comes because of a state of nature, what will be my payoff, right? And as I said, the probabilities are involved. So, question is that these probability, what are the essential concepts of probability, particularly the concept of conditional probabilities are extremely important in this context, because increasingly it is happening that the idea of the Bayes theorem translating the prior probabilities to the posterior probabilities have become a very important concern. And what is really happening? Most of the inferencing that takes place based on converting the prior probabilities to the posterior probabilities, right. When you go to a doctor does an examination, and it basically it is like increasing the probability of really identifying a particular disease based on certain tests and examinations, right. So, those situations of different context, right, whether to make a decision to launch a particular product initiative or not, can be looked into in the decision problems with experimentation, and evaluate the decisions in a decision tree format. The next topic will be the queuing or the waiting lines model. Queuing is everywhere, even when a vehicle is moving on a road, right. When they approach a bridge, the bridge is like a service. The cars that are coming are the arriving cars, right, and cars that are going out may be the served cars. When you are there in the station and you want to buy ticket, basically what is happening? You are getting a service. When in a shop floor the workers are going to get their tools, then they are also going for a service. Usually what happens? Normally the queues are not supposed to happen, right, if the service rate is higher than the arrival rate. But even then, due to probabilistic situations, queues will occur. So, the question is, if the arrival rate is more than service rate, we really require the arrival rate to fall below the service rate. But if it is not, then after we achieve the arrival rate less than service rate, we need to take the help of queuing theory to come up with the appropriate queuing service design so as to optimize. So, we have to look at the first of all the different distributions, the discrete distribution of Poisson and the continuous distribution of exponential. Again there are an equivalence, because most of the queuing analyses are based on such distributions. The birth and death process through which the queuing calculations can be done, and the different types of queues like single server, Markov process queues, multiple server and other models, and also the finite queue space models will be covered, right. And finally, we shall look into the queuing cost models as well as those of what is known as networks, queuing networks. In the third topic, in the simulation, three types of simulation we shall broadly cover: the discrete event simulation, the Monte Carlo simulation and the continuous simulation. Generation of pseudo random numbers and random variates are extremely important, particularly in the context of discrete event simulation. So, real life world can be simulated. Basically, the essential idea of simulation, that if we have a real system, we create a model and we observe the model system in order to predict something about the real system, because experimenting with the real system is costly, right. That is why we go for simulation. The other side of the picture is the continuous simulation. What happens in continuous simulation? We do not need random numbers because events do not occur. We try to simulate through a set of differential equations, and all of these simulations are extremely popular. Very important software are available, and we are able to simulate different kinds of situations to really obtain meaningful results, right. After simulation, our last topic will be the network models. There are lots and lots of problems, combinatorial problems, specifically the network flow problems, the kind of flow that would take place in a given scenario, right, particularly let us say on a road network or a transport network or a communication network. The different questions that come in is what should be my maximal flow, or sometimes what will be the shortest path from one point to the other. Even there are network simplex method where we try to solve graph theoretic or combinatorial problems with the help of the linear programming. But the specific linear programming for network is known as the network simplex method. But all these could only be done, the first week will be devoted to the basic graph theoretic concepts, the concepts of tree and spanning tree and the cuts and cut sets. So, these are our 4 modules, and detailed syllabus, the lecture wise, as you can see that there will be 10 lectures on the decision analysis topics, right. There are 10 lectures on waiting line topics, starting from introduction to distributions to MM1 and finite queue space and queuing cost and so on. For 10 lectures on the simulation topic, simulation, the discrete event to Monte Carlo, pseudo random numbers, random variates, output analysis, variance reduction, continuous simulation and so on. And finally, the network topics, introduction, graph operations, tree, spanning tree, cut sets, fundamental matrices and maximal and shortest path problems, right. And here are some reference books. The Hillier and Lieberman is an extremely important book. There are very good simulation books by Banks and others, and Law and Kelton. There are Narsingh Dev's book on both graph theory, and there is another book on simulation. So, you can go through all these books also simultaneously as you go through the course, right. So, happy going, and let us see how it really runs, right. So, thank you very much.